Good morning, students.
Good morning, sir.
Good morning, sir.
Please tell rest everyone to join immediately. So, Rahul, do you remember in last class what we were discussing about?
Sir, about finishing of the year.
No. Then we have that was in the third module. Then we have started the fourth module.
Sir, vernier calipers and oral things.
Yeah. So all that comes under what? All that comes under the basic measurements, right? We were discussing about the various measurements. I hope so you remember.
Yes, sir.
We were discussing about the various measurements. Okay. So that was the thing. Okay. So like is the screen visible?
Yes, sir.
Okay. So yesterday we were discussing about the metrology instrumentation. As you know, our subject, machine tools and metrology. So basically, we deals with machine tools on the mainly in the first three modules, and in the fourth and the third and the fourth and the fifth module will be mainly dealing with metrology and the various instruments used for checking the measurements, tolerances, types and fits, etc., which we have dealt yesterday itself. So in the case of metrology instruments, that it's mainly the science that deals with measurements that we have discussed yesterday. Then instrumentation process of using instrument measure everything. So yesterday we were in these slides. I hope so you remember while we are ending the class. Like we were discussing about the need for measurements. So in the aerospace application, in the case of constructions and the case of building a furniture, again construction, then even the satellite. So the measurement. So measurement is mainly related to the tolerance, allowances, fit, gauges, everything. It's mainly because it is also related to mainly the precision and accuracy. It's mainly also related to the precision and accuracy of all the aspects. That what happens in the case of measurements. Then yesterday, we have told a small idea about what is the measurement, what are type of measurements, and what is the requirement of a measurement, what is it. So, in order to have a proper measurement, in order to have a best measurement and a proper measure, we always decide with the precision and accuracy. For attaining the precision and accuracy, we have various types of instruments employed. In the last class, we have discussed regarding that. What anyone can you tell me what was the last class we have discussed the various instruments regarding the measurements? Can anyone tell me the last class what were the various instruments used for measuring the instruments? Karthik, Karthik Koseri, can you tell me what was the various instruments used for measuring the instruments? Karthik, are you available over there? Yes, Karthik. Yes. Karthik, can you just tell me what are the basic instruments which are used for the measurements? Last class we have discussed. You don't remember about the vernier caliper, everything? Karthik?
Normally, sir.
Yes. Then what else? Vernier caliper then?
So,
Screw gauge. Okay, fine. Okay. Screw gauge, sine gauges. Rahul, do you remember? vernier calipers, screw gauges, sine gauges, all this was there. Okay. In the case, no problem. In the case of precision and accuracy, the main thing is the terms precision and accuracy are used in connection with the performance of the instrument. Okay, it is always dealing with the performance of the instrument, where while the precision is always the repeatability of the measuring process, while the precision is always the repeatability of the measuring process. Means repeatability means the measurements of all the items which is done through that process will be the same. That for measuring the identical parts to have a formation of various batches and a formation of various numbers. That's what we say in the case of precision and accuracy. So the term precision and accuracy are always used in connection with the performance of the instrument. Are always used with the performance of the instrument. Are always used with the performance of the instrument. Okay, so in the case of precision, it is a repeatability of the measuring process. And accuracy, again, next aspect is accuracy. Accuracy is the degree to which the measured value of the quantity and quality characteristics agrees with the true value. That is mainly the measured value of the quality and quality characteristics agrees with the true value. That is, we will be having the measured value and we will be having a value which has to be attained for the purpose. Okay, in the case of mechanical solutions, okay, it has to be done for the purpose. That's what happens in the case of precision and accuracy. Okay, that's what. So in the case of precision and accuracy, both terms comes under the connection with the performance of the instrument. It is always regarding the performance. Okay, it is always regarding the performance. Okay, it is always regarding the performance of the requirement. Okay. So this is what happens in the case of precision and accuracy. Precision and accuracy. And then comes the errors in the measurement. Okay, when it comes to the precision and accuracy, next one is the errors in the measurement. Okay, errors in the measurement. Errors in the measurement. Okay, that's what happens when it comes in the case of errors in the measurement. So when we are attaining precision and accuracy, at the same time there will be the cause of errors in the measurements. Like errors in measurements are unavoidable. It may be due to human effort or something else, or due to manufacturing aspects, or due to labor issues. Like labor issues means the labor's negligibility, and sometimes change in the values, or sometimes not having proper dimensions, or not having proper weight ratio or proper rate ratios in the case of measurements. All this comes into action. So in the case of errors in measurements means errors in measurements are always unavoidable, and we can only hope to reduce them, and we can always only hope to reduce them. This is what happens in the errors measurement. Then measured value. So an error measurement is a measured value minus true value. That is, always we will be having an instrument. For example, we are taking a laptop. So we will be having a design aspect, and we will be have CAD drawing everything, where we have a true value of the laptop or any components, any mechanical components. We will be having a true value at the time of design. Like for example, length will be 2.5, or height, depth, everything aspects. But when we measure it, there's a change means then automatically it shows the error. Okay, and there is, in case of, there is tolerance state like 0.02, 0.01, all that are applicable, or that can be expressed, or that can be not an issue, can be made available, and can be the purpose will be served. But when the error in the measurement, that the measured value and the true value, there's a huge difference. Automatically the purpose for which the machine might be used in some cases may not be apted, so it may become an obsolete product. That is, it may reject it from the quality check. So as we have discussed like the quality control system, or the quality check, or the periodic quality system. In every company, or in every manufacturing company, we will be having a quality checking department, QC check. Okay, we say it is a QC check, where we have quality inspector, where he will be measuring the proper, not only the values, also the functionality, the testing, the rigidity, everything will be tested, and only then the product will be released for the released for the customer, or for the requirement of the purpose. This is what happens. Now, errors can be expressed in terms of absolute error and relative error. So, in the case of absolute error, you can say true absolute error is always measured value minus true value, and apparent absolute error, then relative error. So, in the case of absolute error, I hope so. The figure which we found on the side, we can understand it is a vernier caliper. So, but in our lab, we have normal vernier caliper, but here what we have a digital vernier caliper. In that, we will be having a reading with the help of a scale. We have a main scale and a vernier scale. Yesterday I have shown the figure of the vernier caliper, and that was the weight scale, vernier scale. The same thing which is been present in our lab, and we have been doing in the case of manufacturing technology lab. Okay, but here we have the same instrument, but we have we have a digital setup where the value itself will be shown in the digital setup. Okay, so now we come to the absolute error. So the true absolute error. Okay, what do you mean the true absolute error? It's defined as the algebraic difference between the result of measurement. It is the difference. It is defined as the algebraic difference between. It is defined as the algebraic difference between the result of measurement and the conventional true value of the quantity measured. In the case of true absolute measures, it is defined as the algebraic difference. Like it is mainly defined as the algebraic difference between the result of measurement and the conventional true value of the quantity measured. That's what happens in the case of absolute error. Means it is always defined as the algebraic. Okay, it is always defined as the algebraic difference between the result of measurement and the conventional true value of the quantity measured. That's what happens in the case of true error. Means there will be algebraic difference between the result of measurement, the result of the measurement, and the conventional true value quantity. There will be an algebraic difference. That's what the value will be different. Okay, mainly we can say the value will be almost different. That's what happens in the case of absolute error. Then it comes with the apparent absolute error. Okay, then it comes with an apparent absolute error, where it is defined as the algebraic difference between the arithmetic mean and one of the results of measurement when a series of measurements are made. That's what happens in the case of apparent absolute error. Okay, that's what happens in the case of apparent absolute error. It is defined as the algebraic. Okay, it is defined as the algebraic difference between the arithmetic mean and one of the results of measurement. Okay, it is defined as the arithmetic mean and one of the results of the measurement when a series of measurements are made. Okay, when a series of measurements are made, that's what happens. Means the algebraic difference between the arithmetic mean and one of the results of measurement when a series of measurements are made. This is mainly done in the quality check. Okay, where we will be hiding the error. So apparent absolute error. It may be due to some scaling operation or metal removing operation or some manufacturing operation or some shaping operation or some design constraint or design aspect operation. All this comes into an account. Okay, by the time of manufacturing, and there will be change in some values. Okay, and in all the cases there will be tolerance, like we can have an excess value or minimum value of 0.02, 0.01 or 0, or in some cases it may be maximum 0.05 also. Okay, this is what happens. For example, what you can say is if you are having a laptop, if your laptop is having a just a 0.5 mm increase in length, okay, when we can modify all the systems to same way. Like for example, we have manufactured a laptop box or a laptop shield or a laptop cover, what we can say, or a laptop base. Okay, mold which is up to in metal. Also, nowadays laptops are coming in metal, not only plastic. So in that case, what happens? You have made 1,000 pieces. So then we can tell the designer to modify the all other parts and make it to a apparent 0.5 increase in the size may not result in the case of a laptop. Okay, but in some aspects, whether mating effect or it may not suitable for the purpose. This is what happens. So this is what happens in the case of absolute error. So you see, this is a vernier scale where we can see the instrument measurements. Okay, this is a vernier scale. Let's see where we can see the instrument measurements. Okay, so this is for the down scales used for measuring the outer one, and the inner scale and the upper one is upper scales used for measuring the inner diameter. That's what happens in the case of a vernier caliper. Okay, that's what happens. Okay, then we comes with calibration and tolerances. Okay, then we comes with the calibration and tolerances. Okay, it's mainly dealing with calibration and tolerances. So when it comes to the calibration and tolerances, what happens is the measurement of the dimensions. Okay, mainly the measurement of the dimensions can't be perfect and reliable unless and until measuring instruments are calibrated. Okay, so the measurement of the measurement, mainly the measurement, but it is always dealing with the measurement. So the measurements of the dimensions can't be perfect and reliable. Okay, unless and until the measuring instruments are calibrated accurately. That's what happens. So in the case of calibration, okay, or we can say in the case of calibration, the measuring of instruments. Okay, in the case of calibration, the measuring and the instruments can be taken. Okay, in the case of calibration, measuring of the dimensions can't be perfect and reliable. So what happens is, unless and until measuring instruments are calibrated accurately, only then the purpose will be achieved for calibration. So, and calibration means what? It is mainly the comparison of instruments, performance to standards known as accuracy. That's what happens in the case of a calibration. Okay, mainly related to the accuracy. Okay, so it is a comparison. It is always the comparison. Okay, it is always the comparison of instruments, performance to standards of known accuracy. It is merely the comparison of instrument performance of standards to known accuracy. And then we can say calibration means so to find out whether the instrument gives the correct reading or not. It also includes minor adjustments in the instrument to minimize error. That's what happens in the case of calibration. So it is merely the measurement of dimensions. Okay, it is merely the measurement of dimensions which can't be perfect. So then why do we calibrate? We can say why do we calibrate everything? So why do we calibrate calibration? Why do we calibrate? For the most part, today's color measurement instruments are 100% digital. In fact, there are very few analog components. So all this happens for the calibration. So we should have a calibration aspect where we have the tolerances and our regular calibrations to with tight specs. In order to maintain with the tight specs, we have calibration. Okay. In order to maintain with the tight specs, we have the various calibration aspects. And calibration means to find out whether the instrument gives the correct reading or not. Calibration means to find out whether the instrument gives a correct reading or not. It also includes minor adjustments in the instrument to minimize error. It also includes minor adjustments in the instruments to minimize the error. Okay, to minimize the error. That's what happens. So this is the main thing of the dimensions. It's mainly related to the dimension aspects. Okay, it is mainly divided into. Then we have various types of calibration, like in-lab calibration, on-site calibration, all that. Okay, all that happens in the case of calibration. So it is one word. In one word, you can say measuring instruments are calibrated accurately. Can't be perfect line until the measuring instruments are calibrated perfectly. Okay, it's calibrated perfectly. Then it's a comparison of instruments performance to standards of non-accuracy. Okay, that's all. So calibration is comparison between known instrument and the measurement using your instrument. Okay, we can one word we can say is what calibration. Calibration is a comparison between. Okay, it is a comparison. It is mainly compare. We can say comparison of instruments to performance of non-accuracy where it's a comparison between a known measurement, that the measurement which is already known, that is the standard measurement, we can say. That's the always the standard measurement. Okay, and the measurement using the instrument, and then the measurement using the instrument. The instruments are used like vernier calipers, also various types of sine gauge, screw gauge, all that instruments are used. So typically the accuracy of the standard should be 10 times the accuracy of the measuring device being tested. Hence the accuracy of the scale is a main parameter for the calibration. So the what of the scale, like a vernier scale or screw gauge or sine gauge, anything, the accuracy of the scale is the main parameter. Okay, it's the main parameter of the calibration. So it is okay. So why do we calibrate instrument? We calibrate an instrument for comparing a device under test. Okay, whether it is optimal for known value with a reference standard of known value. Why do we calibrate? Why exactly the calibration is requirement, or why does the calibration is required? Because why the calibration is required means what? Calibration is an act of comparing a device under test. Okay, it is mainly the act of comparing a device under test of an unknown value. Of an unknown value with a reference of a standard of a known value, but we will be having always a known value, but of an unknown value with a standard. Then a person typically performs a calibration to determine the error or verify the accuracy of the unknown value. This is what happens. Okay, so of the device under test unknown value. So we calibrate for like in the lab, in the laboratory also, we calibrate various instruments since what to know whether are they having an enormous amount of error, whether there is an enormous amount of error or maximum amount of errors occurred. All that as compared to the case of calibration where we should understand whether the system. So we calibrate after every year or after 2 years of time or after every semester in order to attain the maximum measurements, the perfect and the maximum measurements for the output. Not attain the perfect and the maximum measurements after requirement. That's what happens. So this is what happens in the case of calibration. Okay, then why it is being used, as I told, the goal of calibration is to minimize the measurement uncertainty by ensuring the accuracy of the testing equipment. So the main goal of calibration is what? Since we are doing all this measurement dimensions, comparison to instrument is correct reading or not, all this is done. The main goal of calibration is to minimize any measurement uncertainty. To minimize the any measurement uncertainty. Okay. To minimize the any measurement uncertainty by ensuring the accuracy of the test equipment. For ensuring the accuracy, mainly for ensuring the accuracy of the test equipment. This is what happens in the case of calibration. So, main goal is to calibrate and to minimize the measurement uncertainty. To minimize, to come to a very close value or come to an almost very close to the correct value or adjacent value. That's what. So, the goal of calibration minimize any measurement uncertainty by ensuring the accuracy of the test equipment, where it controls or quantifies the errors or uncertainties. It mainly controls or quantifies the errors of uncertainties with measurement process to acceptable level. Then we can say there are various types of calibration according to our requirement. We can say pressure calibration is there, then temperature calibration is there, then flow calibration is there, pipette calibration, electrical calibration, mechanical calibration. All of them according to the purpose and requirement we have. But in your model, we don't have a detailed thing. I just said it when we are talking about calibration. There are different types of calibration, like pressure calibration, temperature calibration. Pressure is always the how to calibrate the pressure, the temperature calibration, the amount of flow calibration, and electrical calibration. Then in the mechanical aspect, mechanical calibration. Okay, so when it comes to calibration, is this where the least count. Okay, least count is what the value of the minimum, as we are told yesterday itself in the case of vernier caliper, the value of the minimum division. Okay, the value of the minimum division of the main scale and the number of divisions on the vernier scale. This is what happens in the case of a vernier scale. That's the least count. Okay, value of minimum divisions on the main scale and the number of divisions on the vernier scale, and the smallest value that can be measured by the measuring instrument. And this is the smallest value. This is the smallest value can be measured. So you can see in this one. Okay, so you can see in this one. This is the same vernier scale which we have in this is cursor. This is the same vernier scale which we have in our lab. Okay, we have a main scale. We have the main scale, and this is the vernier scale. Vernier scale. And in the previous slides I have showed. Okay, in the previous slides I have showed the same thing with, see, this is a digital measurement. Okay, this is used for a digital measurement. That's the difference. So nowadays you can, it is also easily available, but in modern times, but it makes like this is only done for high precision accuracy, but only it what happens, it destroys the skilled labor. It to improve the ability of measuring, it destroys the skilled labor. That's what happens in the case of calibration. Okay, so this is the smallest value. Then if actually the different types of calibration is this, and means okay, so any one of you say by understanding what do you mean by this calibration in one word? I'm not going to pinpoint any of the students. Anyone, can you say what do you mean by calibration? I have told what you mean by calibration, different types I have told. Then why, what is calibration, why it is being used, all I have told. Can any one of you say me what do you mean by the calibration? Okay. Can any one of you tell me what do you mean by calibration? At least in a sentence. Should I call up your name? Should I call up your name? See here, 20 students are available.
Sir, it's a process that done to reduce the errors.
It is a process that
Done for reducing the errors.
okay. It is a process done for reducing the errors. Okay. Okay. Errors of what?
Errors in measurement.
Thank you, Vishnu. Thank you. Errors in measurement. That's what happens. Mainly to calibrate the instruments. Okay. Mainly for calibrating the instruments. That's what. Mainly for calibrating the instruments. So we can say correct. Thank you, Vishnu. So the definition of calibrate means to correct or to adjust the graduations of something. Okay. Mainly to correct or adjust the graduations of something. Mainly to correct or adjust the graduations of something that measures in comparisons to a certain standard. That measures in comparison to a certain standard. So we can say, for example, to calibrate is to move an iPhone compass into correct position. An example to calibrate you set to scale 0 is to measure a caliper of a tube or a gun. This is what happens in the case of a calibration. So Now we can say in most of the thermometers, what's calibrated thermometers? Like a thermometer is calibrated by measuring a series of temperature, fixed points, freezing, melting points, triple points, or vapor pressure points of your metal. By using this method, we insert the thermometer in a fixed point cell, which provide the desired temperature. So see, we can calibrate a thermometer. So these are the examples. Okay, we are saying we are just mentioning about the examples. Okay, of a calibration. Okay, so when this comes to calibration, it comes to another of other means mainly to the principles of achieving the precision, accuracy, tolerance, allowances. All this comes into the factor. Okay, in the case of calibration, all this comes into the factor. Okay, so with respect to surface toughness, everything comes into a factor. So like now we can say an example of thermometer, for example, a basic thermometer. I hope so. You all will be having a thermometer in your home. So okay, so you can calibrate your thermometer to check whether the value is given by the thermometer same, because nowadays due to this pandemic everything you require thermometer to check the temperatures everything. So for that you can have a thermometer in your home. So in the case of thermometer you can calibrate the thermometer. Since if you are having a very old thermometer, you can just calibrate and check whether the value shown by the thermometer for different temperatures are normal or same, or very correct or very near to the exact value. If there's any issue to the thermometers like that. For that, what we do is a thermometer is calibrated by measurements at a series of temperature fixed points like freezing points, melting points, triple points, or vapor pressure points, pure metals. By using this method, we can insert the thermometer in a fixed point cell, which provides a desired temperature. That is, we should know the already temperature for like boiling of water 100 degrees. All that we can know. So we can insert temperature of the thermometer and check whether the value is correct or not, and how to have it, this kind of everything. This is what happens. Okay, then there are various points according to the purpose, according to the requirement, and according to everything, and according to the functionality. There are various points under calibration. Okay, there are various points under calibration. So this is what happens in the case of calibration, where there are different points. Okay, so the point is what it is having 3-point calibration where high, middle, and low out. So that's what we say in slide. Like it includes minor adjustments in the instrumentation to minimize error. Okay, this is what we say in the slide. Like it also includes minor adjustments to increase or minimize the error. So this is what happens. So this is the calibration. Now after calibration, okay, after calibration we will be having we will talking about the surface roughness and the functional irregularities, all that stuff. So before that, we will have just an overview of okay the measurement. Okay, this is a topic where we have to complete the we have discussed. So in this module, okay, in this module, what we have discussed, we have started with the introduction to metrology. Okay, we have started with the introduction of the metrology, what we mean by metrology and science. Okay, then we have discussed the various measurements of instruments, devices, everything. Then we have been dealing with the need for measurement. What are the need for measurements? What is the requirement aspect, and what are the factors for the measurements? Then when we have been dealing with the precision and accuracy. So in order to measure, after measuring the instruments, we will be always relating to the precision and accuracy, which is always in connection with the performance of the instrument. Which is always in connection with the performance of the instrument. Okay, so it is only connected with the performance of the instrument, where the performance of the instrument can be connected with the precision and accuracy to an extent only. Like what? To extent means always the instrument to perform the best way. It should have a high precision rate and high accuracy. Like we should be calibrated. We should have to calibrate. Okay, we have to calibrate. Only then the instrument will be having the fine tuning or the fine aspect where it is required, or it will be serving the purpose. This is what happens. Then in the case of precision, it is a repeatability. It's mainly the repeatability of the measuring process. Okay, it's mainly the repeatability. And then accuracy is the degree to which the measured value of quantity is measured. That's what happens. Then for attaining precision and accuracy, while attaining precision and accuracy, there will be errors in the measurements. Okay, sometimes while valuing the error, while designing, or by manufacturing, there are various aspects how the errors can occur at the time of manufacturing or at the finally the final product. Okay, so in that case we can say the errors are different, expressed in different terms. Like errors are measured manually, we can only hope to reduce them. So errors in measurement is always the true value. We have a desired value what has to be attained from the designer or from the final product. But then we will be having a quality control or quality aspect checking, whether after the final product is arrived, to check whether it is It is meeting all the dimensional accuracies. For that, we will be having a measured value. So according to the purpose of the requirement and according to the instrument structure, everything, we will be having various measuring devices. Okay, commonly used measuring devices in case of centimeter measurements is vernier caliper and screw gauges. All that are used. Okay, even in the case of gears also, we make use bolt type screw gauge. Yesterday we had discussed bolt type screw gauge will be used. So then error, and we can find out the error. And if the error is a minimum, like we can say 0.01 to 0.05, all that, it is, in some cases it is negligible, or some cases it is according to the purpose. We can quantify and we can list it out, and some cases we can use it for the purpose, and some cases we have to reject it for the purpose. That's what happens in the case of error. Okay, then in the case of it, then we have the main thing is about the absolute error. Okay, then we have the main thing is about the absolute error between the results of measurement and the conventional true value of the quantity measured. And then we have the apparent absolute error. It is defined as the algebraic difference. It is always the algebraic difference between the arithmetic mean. It's always the algebraic difference between the arithmetic mean and one of the results of measurement. Where a series of measurements are made. Where always a series of measurements are made. Okay, then comes the vernier caliper instrument. Then we have the calibration. Okay, then the calibration. So calibration is mainly done for achieving the maximum accuracy and precision. For achieving the maximum accuracy and precision of the instrument, it's mainly done for achieving the maximum accuracy and precision of the instrument. So for achieving the maximum accuracy, accuracy means to an extent. What we can say in the case of accuracy, it is to an extent. Okay, like the product has to be built in such a way that the maximum accuracy has to be attained. Okay, to attain the maximum accuracy. Okay, this is what happens to attain the maximum accuracy. So this is what happens in the case of accuracy. And calibration means to find out whether the instrument gives. Calibration means to find out whether the instrument gives the correct reading or not. And it also includes the minor adjustments. Okay, and it also includes the minor adjustments to an aspect. Minor adjustments has been done for the instrument to minimize error. So all this comes into the calibration. Okay. Then, in order to have an example, we can say that surface reference. Okay. In order to have an example, we can say what an surface reference. So this is the surface reference. Okay, like reference of the waveless height, then reference height, everything comes into play. So the factors affecting the surface reference, you see, material of the tool and workpiece, types of machining, then cutting parameters such as speed and depth of cut, vibrations, types of coolant. So these factors affecting surface roughness. So in order to surface roughness, what is the material we use in order to have a surface roughness and polishing? What are the various types of devices which we use for surface roughness? Can anyone of you say? We have studied in the last module. Can anyone of you say, with respect to surface roughness, what is the type of instruments which are used or applications? Anyone? Anyone?
Grinding.
Grinding, yes. You are right. Grinding. Then? We have just, yesterday only we have completed the third module and we started the fourth module. Grinding is a very important point then.
Broaching.
Okay, so in all this, how does this precision and accuracy comes into factor? Can anyone tell me? In all this, how does the precision and accuracy comes into factor? Anyone of you? In all this, how does this precision and accuracy comes in the factor? In all this, how does the precision and accuracy comes in the factor? Any one of you? If you have just a basic idea, also just tell me.
Sir, in grinding, if we grind
Uh,
sir,
in grinding,
sir,
tell me. Yes, Rahul, tell.
സർ ഒരു പരിധിന്റെ മേലെ ഗ്രൈൻഡ് ചെയ്താൽ ആ ഡയമെൻഷൻ തെറ്റില്ല.
Okay, dimension aspects is a very important factor. But my question is, in grinding, we have a grinding teeth, right?
യെസ് സർ.
So if you don't calibrate the grinding teeth, after regular usage, what will happen?
വീൽ സ്പീഡ്
The wheel teeth sharpness, edges, everything will what happen? Deteriorate, right? After regular usage, the wheel sharpness, length, height, everything will deteriorate, right?
യെസ്.
So automatically what happens when we are using it, what happens? Automatically we will understand that what the wheel is been worn out and it may lose the ability to do the purpose. That is the surface finish to remove surface roughness. So what happens? Automatically it may destroy the workpiece, which is almost the final product. So in order to check all this, we should calibrate them. We should calibrate, right, to check whether the wheel has been done or not by having by checking the dimensions. Okay, we must be knowing before a new grinding wheel, what will be the dimension of the teeth, the depth of the teeth, the angle of the teeth, everything we will be knowing, the dia of the wheel, everything we'll be knowing, right? So after the usage, what happens? Okay, so after the usage, what happens? After the usage, what happens is automatically what happens? The values will change. So we have to calibrate on, we have to check the accuracy, that is the closeness, the proximity has to be measured. Why? To produce the correct result. So for that we require an accuracy of instrument to use to specify the percentage of instrument span, like how much time, like for example a grinding wheel in the case of surface roughness or a broaching tool, okay, which have number of teeth, all this will be having a lifespan. Lifespan means we can say working hours, like we can say working hours. So this wheel is being used for this much hours. Automatically what happens? Okay, so what happens? All this comes into action where we have a final output. Like what we can say, my final output means the instrument that usually specifies a percentage of instrument span, like what is the span, what is the requirement, everything has to be considered to achieve the accuracy. Okay, to achieve the accuracy, this is what happens in the case of the measurement and regarding the accuracy rate. Okay, so all this comes into action. So the next class we will be having an explanation of the tolerances and allowances. Okay, for time being we will stop here for today. Okay, and I shall take the attendance by the meantime. Okay.